The Transients Exoplanet Survey Satellite is a space telescope for NASA's Explorers program. Designed to search for exoplanets using the transit method in an area 400 times larger than that covered by the Kepler mission. It was launched on April 18, 2018, atop a Falcon 9 rocket and was placed into a highly elliptical 13.7-day orbit around the Earth. The first light image from TESS was taken on August 7, 2018, and released publicly on September 17, 2018. Over the course of the two-year primary mission, TESS was expected to ultimately detect about 1,250 transients exoplanets orbiting the targeted stars, and an additional 13,000 transients planets orbiting additional stars in the fields that TESS observed. As of the 5th of April 2021, TESS has identified 2,601 candidate exoplanets, of which 122 have been confirmed so far. After the end of the primary mission around July 4, 2020, data from the prime mission will continue to be searched for planets, while the extended mission will continue to acquire additional data. The primary mission objective for TESS is to survey the brightest stars near the Earth for transients exoplanets over a two-year period. The TESS satellite uses an array of wide-field cameras to perform a survey of 85% of the sky. With TESS, it is possible to study the mass, size, density and orbit of a large cohort of small planets, including a sample of rocky planets in the habitable zones of their host stars. TESS will provide prime targets for further characterization by the James Webb Space Telescope, as well as other large ground-based and space-based telescopes of the future. While previous sky surveys with ground-based telescopes have mainly detected giant exoplanets, and the Kepler Space Telescope has mostly found planets around distant stars that are too faint for characterization, TESS will find many small planets around the nearest stars in the sky. TESS records the nearest and brightest main sequence stars hosting transients exoplanets, which are the most favorable targets for detailed investigations. TESS uses a novel highly elliptical orbit around the Earth with an apogee approximately at the distance of the Moon and a perigee of 108,000 kilometers. TESS orbits Earth twice during the time the Moon orbits once, a 2:1 resonance with the Moon. The orbit is expected to remain stable for a minimum of 10 years. Led by the Massachusetts Institute of Technology with seed funding from Google. On April 5, 2013, it was announced that TESS, along with the Neutron Star Interior Composition Explorer, had been selected by NASA for launch. On the 18th of July 2019, after the first year of operation, the southern portion of the survey was completed, and the northern survey was started. The northern survey was completed on the 4th of July 2020. The concept of TESS was first discussed in 2005 by the Massachusetts Institute of Technology in 2015, allowing production of the satellite to begin. While Kepler had cost $640 million United States dollars at launch, TESS cost only $200 million United States dollars. The mission will find exoplanets that periodically block part of the light from their host stars, events called transits. TESS will survey 200,000 of the brightest stars near the Sun to search for transients exoplanets. TESS launched on April 18, 2018, aboard a SpaceX Falcon 9 rocket. In July 2019, an extended mission 2020 to 2022 was approved. On January 3, 2020, the Transit Exoplanet Survey satellite reported the discovery of TOI 700D, the first potentially habitable Earth-sized planet. TESS is designed to carry out the first spaceborne all-sky transients exoplanet survey. It is equipped with 4 wide-angle telescopes and associated charge-coupled device detectors. Science data are transmitted to Earth every 2 weeks. Full-frame images with an effective exposure time of 2 hours will be transmitted as well, enabling scientists to search for unexpected, transient phenomena, such as the optical counterparts to gamma-ray bursts. TESS also hosts a guest investigator program, allowing scientists from other organizations to use TESS for their own research. The resources allocated to guest programs allow an additional 20,000 celestial bodies to be observed. In order to obtain unobstructed imagery of both the northern and southern hemispheres of the sky, TESS utilizes a 2:1 lunar resonant orbit called P2, an orbit that has never been used before. TESS will downlink to Earth over a period of approximately 3 hours the data it has collected during the just-finished orbit. TESS's 2-year all-sky survey would focus on nearby G, K, and M-type stars with apparent magnitudes brighter than magnitude 12. Approximately 200,000 stars were to be studied, including the 1,000 closest red dwarfs across the whole sky, an area 400 times larger than that covered by the Kepler mission. TESS was expected to discover more than 20,000 transient exoplanets, including 500 to 1,000 Earth-sized planets and super-Earths. Of those discoveries, an estimated 20 could be super-Earths located in the